You good? Good.
Are we good?
All right. All right. Let's get started. This is not a talk about data recovery or pornography. This is Canary in the Cloud. My name is Scot Bernerv. I'm a Christian, husband, father, security guy. I like to wakeboard. I like to shoot things. As you may have known, I'm a first-time speaker. There's my Twitter handle. And I work at a company named Synercom, doing consultancy, mostly red team type work. So, just want to say thanks to the DerbyCon staff and the people who waited through the wonderful booth up there, and just really appreciate being able to speak here, given the opportunity. It's great. Really appreciate it. First thing I want to go over is just kind of detail what the goal is of this talk, and the approach I'm taking is to give you a novel approach to honeypotting that allows a defender to detect an adversary prior to the attacker achieving their goal. So as the attack progresses, hopefully this approach will give you that one-up that you're able to detect and stop them prior to them achieving whatever it was that they're looking for in your environment. Is everyone here familiar with what a honeypot is? Anyone not familiar? Okay. I will go very quick. Honeypot is basically just a trap. It's an electronic trap designed to catch someone doing something. There's an interesting history of honeypots, and the first instance of it that I could find was in a book by Cliff Stoll. Very good book, The Cuckoo's Egg. And basically in this book, he was actually an astronomer. Astronomer? He does astronomy. And he also got kind of pulled into doing some programming, and through that he noticed this discrepancy in his network, and he chases this hacker around his network, and he ends up building this fake Department of Defense program that lures this guy to stay on the wire long enough so they can actually do a physical telephone tap, which is kind of interesting. There's basically two types of honeypots. I'll go real quick. Low interaction, high interaction. High interaction honeypot is basically just an emulated operating system. Low interaction is just like an emulated service. The low interaction is easier to secure, easier to maintain, set up. So that's what I really focused on here. And then there's this concept of the canary. And if you're familiar with like old school coal mining, the canary was just a bird in a cage. They brought it in the mine. If there was noxious gas, the bird would die. And then they'd know it's time to get out. So the idea here with a honeypot is you set up some kind of tripwire. The adversary trips the wire, and then you know it's go time. So that's basically that. The novel approach that I'm laying on top of here is kind of a hybrid cloud configuration so that your canary is within your network on your interior, but the actual honeypot is in the cloud. So you don't have to have this vulnerable system in your internal network, and there's really nothing valuable for the attacker to get at once they get into your trap. So what kind of problems do organizations face when they're trying to put in a honeypot? There's just a couple here that I really wanted to address, mainly helping out with the first two. A lot of people would say, hey, why would I put a honeypot on my network? It's vulnerable. It's going to allow the attacker to, maybe launch DDoS attacks from my network or pivot from there, give them a toehold. There's also some people would bring up the legalities of honeypotting as far as different laws that are in place, different acts, different concepts within law enforcement, maybe a lawsuit, civil penalties. Maybe there's just a straight technical barrier. Maybe they just don't have the staff that could be adept enough to throw a honeypot on the network and manage it. Maybe they just don't have the business backing. So I'm going to address the first two. The last two are more of a non-technical problem. So basically, when you're talking about legalities of honeypots, there's three key sections that you can address, and I'll go through them one by one. The first one is part of U.S. code called the Electronic Communications Privacy Act, and it's Title 18. It basically deals with what kind of privacy a user of a certain system could expect. And part of that is also the Wiretap Act, which says, if you're allowed to monitor your employees' phone calls, things like that. The last one that people kind of talk about a lot is called Entrapment. I'm sure you're all familiar with that. Setting a trap for someone to get arrested, basically. We'll deal with that later, too. So the first one, the ECPA, or the Electronic Communications Privacy Act, has a setup within the code. It's actually really interesting. I didn't think this would be interesting, but you should read it, because it has a lot of cool stuff in there about intelligence gathering, foreign governments, and things like that. But they also have this provision, or a definition, I should say, of who's covered under this act. And it kind of outlines, electronic, mechanical, or other device, and then it goes on to say, other than, and the second piece of that is a device being used by a provider or a wire of electronic communication service in the ordinary course of their business. So if you're operating a network for your business, you are exempt from this portion by definition from that page. If that doesn't convince you, later on there they have the next definition, which is a computer trespasser. And if you read that, it says that a trespasser is a person who has breached a boundary to protect a computer without authorization and thus has no reasonable expectation of privacy. So it kind of covers that. The next portion of that code, there's a whole section that's referred to as the Wiretap Act. And the gist of this is that you need to have consent. So it may sound like a bigger problem than it is, but it's relatively simple. If you're setting up this honeypot to catch an insider threat, you'll have an acceptable use policy that kind of has them waive any right they have to this act. If that's not the case, if it's an external attacker, you need to make sure that you have set up with your technology consent as they go through your network. So that's usually done in the course of like a banner. So it's like if you click this link, or if you go past this point, if you look at this port, it says, hey, you're consenting to full monitoring and you have no rights, basically. So the last one is entrapment. I put entrapment last because it was the easiest to deal with. The straight Black's Law Dictionary just says a law enforcement officer or a government agent's inducement of a person to commit a crime, and by means of fraud or undue persuasion in the attempt to later bring criminal prosecution against that person. And so if you're not a law enforcement officer or a government agent, I wouldn't be concerned with that. So next, I kind of wanted to introduce this concept of building your battlefield. And this is more defender focused. Kind of wanted to address, how a red team, blue team interact, and some of the paradigms that are there, and something that I kind of think is as a fallacy. And I don't know how many of you have heard this, but you'll hear a blue team person commonly say, well, it's just not fair, because the red team person only has to be right once, and I have to be right every day, all the time, and how can I ever win? And basically my premise is that the red team having to be correct once is not necessarily true. And so for the red team to win, they have to have a series of successes. It's not a single phase, it's not a single step. So red team would have to have successful recon. That recon would have to turn into a successful attack vector, XYZ, getting through their network. If their goal was to get your crown jewels, there has to be a path there. So basically I'm talking about this, the defender's advantage. And the advantage is this. If you think about it in a military sense, if you were going to fight a battle, and let's say you're on one side or the other, and one side gets to just completely build the environment. So, I show this picture of this ridiculous building, but think of it in that way. You have full control over the environment. You can build it however you want. You can make it as painful for someone to get to what you're trying to protect as you can possibly imagine. So, how do you do this? I'm just going to go through one way that I did it and kind of talk about it. So, this is just a list of some open source projects that I leveraged, kind of integrated. I'm not necessarily a developer, but I like to think of myself as an integrator. So the first project is called the Modern Honey Network. And basically what this does is it takes all the complexity of setting up a honeypot and really simplifies it. There's a nice polished app. The people from ThreatStream are supported by Google Ventures. They have really good documentation. You set it up. It's kind of like a next finish, and then you have a honeypot. The second one is called Security Onion. And if you're not familiar with Security Onion is It's a Linux distro built for the purpose of network security monitoring. And so that really gives you full packet capture. You can dissect things, pull objects back out of the traffic. You get logging. It's really fantastic. So anything that happens across a link that's monitored by Security Onion, you can pretty much reverse and see what's going on. It provides alerting, and it's really actively developed. They just recently had an LLC now, so if you need corporate support, it's there. The next couple are just some of the honeypots that I leveraged. Glassdoff is kind of like a web application-based one. Kippo, I'm sure a lot of you are familiar with, is SSH. Dionea is it's mostly helpful for malware, catching malware or drop binaries. And then the last one is the one I use the most, is just basically kind of like a honeyports service-emulated honeypot, and that's called Amon. So that's for like Telnet, FTP, services like that. So what you're going to need, in addition to that, is just a couple virtual private servers, cloud instances. I used Amazon and Azure, but if you have like a bulletproof provider and like a non-extradition company or country, that's probably even better. Then basically what you got to do is kind of patch these together. And the way you do that is by tunneling. And so you have a bunch of different options for tunneling, and I'm sure there's more than I detail here. But I used a variety of these, and I'll kind of go into detail about that. The last piece I kind of tacked on here is called the Collective Intelligence Framework. So what that does is all the data that you're gathering, or that you get from your honeypot, you can kind of feed it back into this Collective Intelligence Framework, and that will give you an idea of if you want to push like ACLs to a firewall to like auto shun or anything like that. It can really help you build and organize your threat intelligence, which is kind of like a big buzzword lately. So really recommend that, and that's all free except for the cloud servers. It's really not too expensive. So here's kind of a diagram of what that kind of looks like. You can see the green highlighted area would be like your internal protected network, and the blue kind of shaded area would be what's running in the cloud. And so that's like in the cloud, you have your honeypots, you have your network security monitoring, and then obviously you have your own internal protected assets within the green part. So this is literally the setup for MHN, which is the honey network. It's like 7 lines, runs. When it's done, you have a nice web interface. I tested it on Ubuntu 12.04, ran really well. So you set this up on one box. On your second box, you install Security Onion, which is a full-blown distro. The wiki here has great instructions. There's a good forum, good support here. I ran that on Ubuntu 12.04 as well. And so that would be your second box. Once you have that set up, you start to add the honeypots. So what I do recommend, if you're going to do this, is kind of think intelligently about what you want to emulate. What would an attacker be looking at in your network? There's just a couple options here I gave you. If you're trying to protect a website, maybe look more to like Glassdoff. If you're just going to look to catch someone, you might be able to just tack on like an FTP service or something like that you could monitor. So once you have that, then you basically start with your tunnels. You start tunneling all the traffic to your honeypot from your internal network. So here's a couple examples. S-tunnel is basically an SSL encrypted kind of like a port redirect. And I have just a sample configuration there that will take a packet when it arrives at a certain port, encrypt it over SSL, send it to the cloud, and decrypt it, and put it into your analysis. So it's not encrypted when it hits your network security monitoring, so you can still see everything in plain text there. I recommend S-tunnel, works really well. If you're in a real hurry, I would recommend RINetD, which is just a simple TCP wrapper that forwards the packet to your honeypot as well. I did notice that Ed Scotus in the keynote had a quick command line netsh port redirect. I haven't been able to play with that, but that might work really well for Windows, but it's kind of the same idea. Placement. So this is probably one of the most important pieces of the whole thing. So if you don't put them in the right place, it's not going to give you a whole lot of value. But you kind of, if you have like a pen test report or recent incidents that have been of kind of major incidents, look at the path the attacker took through your network, and then kind of plan your honeypots to the internal pivot points. That's the best that I could suggest there. So now what? So now you have this set up, and you can start using it. How do you leverage it? I would suggest deception. And so one of the things that I think about as a red teamer is that there's certain situations that if I run into in a network, I'm not going to be able to help myself if I feel like I'm going to get that wonderful compromise or that shell back to me. If I see MSO 8067, I'm probably going to try to exploit it. If I see, old versions of certain services, I'm definitely going to go that way. I'm lazy, right? I just want my shell as quick as possible. So most attackers are the same way, and you can use that to your advantage as a defender. Here's just a couple suggestions. I was going to say also as an attacker, one of the things I really trust is Nmap. So if Nmap is lying to me, I'm going to have a problem, right? So I'm basing my decisions on what my tool is feeding me, at least from Nmap. I'm not doing a packet header dissection and making sure the TCP fingerprints match. No, I'm just running Nmap. So just a couple ideas there. You can have ports open with no services. You can have redirected services, like maybe a web server. Maybe it's like Apache running on Windows or IIS on Red Hat. You can do that when you redirect the port to something else. So basically, the world is your oyster here. Get creative and enjoy this as a defender, because this is your chance to really bear down pain onto someone that's trying to take over your network. I don't know about you, but to me, that's enjoyable. So I didn't want to go into this too deep, but one quick slide I wanted to say about attribution. So given this path that you have, if you make the adversary have something that's very enticing, you can leverage that to get some attribution. So maybe it's like it looks like a VPN access portal, but they have to run a jar file. Well, maybe that jar file actually does a bunch of investigation on their machine, gets their real IP, things like that. And I don't know if you guys have looked at it, but there's an active defense distro from John Strand and crew that you could really leverage here. Maybe get actual real geo IP or geolocation data. Pretty much endless possibilities there. Once you have this attribution, you can use it, not necessarily to get them arrested, although I put that on there, but you may be able to get information like, well, am I being attacked by a robot, or is it someone at a keyboard? Because that's really going to change your security program quite drastically. If you're only going against automated attacks, let's say you just suffer from drive-by downloads all the time, that's going to be something you can easily fool, since it's going to be automated. You can understand these threat actors and what they're doing against you, and that's just going to leverage you, give you a lot of information to how you're going to form your security program. Once you get the techniques, tactics, procedures that are effective against you, that's what you can really target and make ineffective against you. Basically, the whole thing is kind of culminating in a higher level understanding where you need to shape your security program and what you can do with that. So another use of the data I had here was feed your blinky lights. I'm sure everyone has a pretty standard security stack. They probably have an IPS, IDS, and a firewall. Once you have data from this, if you want to get real aggressive, you could have an auto script that just loads an ACL onto your firewall that will stop an attack. So here's that diagram I showed earlier. I'm going to go into kind of what it looked like set up and some of the data I gathered from it. This is probably hard to see, but this is basically the config file for the port redirection that I had. And on the other side, where the honeypot was, is a list of the honey ports. So I had a huge selection of ports. I could use whatever I wanted. I just used FTP, Telnet, SMTP, and RDP. They're real common. I knew I'd get a lot of attention on the internet with those ports. So this is a tool called ELSA. It's built into Security Onion. It's a fantastic logging tool. I basically just did a group by of the attacking IPs. And this was within like 2 hours. Obviously, it's on the internet. You don't want to see this much activity on one that's in your internal network. That'd be bad. But you can see I have at least a good amount of data from who's attacking me. You can see some of them are all from the same subnets, things like that. You can do geolocation. It's not super accurate, but you can kind of get a good idea. This is within MHN. As you'll see, these are all the same IP, because that's just the IP that I was pivoted on from the port redirection. So I would suggest this approach, not so much this one. But MHN also has a nice mapping feature. It would make more sense to have like a map of your internal network in here. Maybe have your segments. You'd have an idea of which ones are going from which zone. But that's all I have. If anyone had any questions, I'd be happy to answer.
You were talking about what ports to have open, the services that get attacked a lot. Run through this one more time.
It was FTP, Telnet, SMTP, and RDP.
I worked for Bernerv. We did a little bit of an impromptu study, and we had basically a piece of software that was boogerjack between basically the building I was in. The switches were in hub mode because they couldn't figure out a networking issue at the university. So
That's
every
convenient.
packet came to my desk, came to your desk, came to his desk. So we had a piece of software that basically geolocated the origin of all of the requests coming in. And China went after 80 and 8080 for proxy.
Oh, sure.
And then Russia went for 443. Actually, China went for 5800, 5900, 3389, and then any proxies. And then Russia was looking for a way to get in and get the cache. But
Nice.
we would get hit 30,000 times in a single month, just on our network segment there.
Yeah.
And it's interesting what people go after, but we can look and see who was doing what.
If I had time, I would have really liked to tailor this to the bash bug, and I would have had a bunch of data about that. But I just...
DEFCON, just do the DEFCON.
Mr. Lang.
So getting a honeypot into the enterprise would be difficult. So what advice would you give to enterprise employees who might want to run this? How would you recommend selling it to management who might not just receive that?
Honestly, I think the best approach would be to have it set up outside the enterprise, get some data, show with your hard data, show the value that you can bring with it.
Set it up on your own?
Yes, first. If your management doesn't like hard data, then you have a problem. Anything else? All right. Thank you, guys.
This is your first talk, right?
Second, technically.
Okay.
It was a month ago.
Okay. You did a very good job.
Oh, thank you.